Hi, my name is Brandon and I'm presenting our work towards applied remapped physical virtual interfaces, synchronization methods for resolving control state conflicts. Remapped physical virtual interfaces combine the haptic retargeting perceptual illusion with physical user interfaces. Haptic retargeting enables the reuse of passive haptics for dynamic virtual objects. Remapped interfaces leverage this technique to create dynamic user interfaces in virtual reality that have the real haptic feedback of a physical interface. In previous research, remapped interfaces have been limited to push buttons. These are a few examples, including some of our previous work exploring the underlying idea of remapped interfaces, as well as handheld remapped interfaces and various reset techniques. Fike et al. Investigated the scaling of linear movement using visuo-haptic illusions. As part of this work, they presented an example system that maps one physical slider to multiple different length virtual sliders using haptic retargeting. This is achieved using a motorized slider to match the physical and virtual slider states based on a log of previous virtual slider positions. Stateful controls like sliders are inputs or controls that hold a fixed state between user interactions. Perhaps the most simple stateful control is a switch. A switch can either be on or off, and the state is only changed by the user. These controls are found in both real-world interfaces like a light switch and throughout many different immersive virtual environments and virtual user interfaces. The challenge with integrating stateful controls with remapped interfaces arises when one physical control is mapped to multiple virtual controls. In this scenario, the state of the physical control is unlikely to match all of the corresponding virtual controls. The motivation of our work is to build upon prior research to explore how we can extend remapped interfaces to include a larger variety of stateful controls. In particular, we want to support sliders, knobs, and switches. The ability to use these stateful controls within remapped interfaces would expand the applications in which the technology can be used. We also want to find a way to extend this to interfaces that don't include motorized controls, such as everyday interfaces like light switches, or more advanced interfaces like aircraft simulators. Finally, we wanted to explore how a passive haptic interface without haptic retargeting compared to a remapped interface. We defined two types of state synchronization, automatic and manual. The names are fairly self-explanatory. In the automatic method, the physical and virtual controls are synchronized automatically. In the manual method, the user is required to manually synchronize the control states. The state synchronization occurs between when the control is selected and when the user interacts with the virtual control. In the automatic method, motorized controls are used to synchronize the physical control to the state of the selected virtual control. For sliders, we use readily available motorized sliders often found in studio mixing desks. For knobs, we initially tested motorized rotary potentiometers, however we found they moved too slowly. Instead, we used a motor with physical end stops to limit the rotation and an encoder to measure the position. For switches, electromechanical actuated toggle switches proved to be extremely rare or expensive, so we developed a custom 3D printed servo actuated toggle switch. The outer casing operates an internal toggle switch, enabling us to measure the current state. The servo then enables us to automatically synchronize the physical and virtual switch states. In the manual synchronization method, the user is shown both a physical and virtual state of the controls. The state of the physical control is shown in orange and the target state is shown in blue. Once the physical state has been matched to the target virtual state, the virtual and physical controls are linked. Then the user can operate the control as normal. As with the automatic synchronization method, the manual method was implemented for the sliders, the knobs, and the switches. We conducted a user study with the aim of comparing the state synchronization methods and exploring the usability of the remapped interface with and without haptic retargeting. We recruited 24 participants and we used an Oculus or MetaQuest to present the virtual environment and enable hand tracking. In previous studies, the interaction tasks have been entirely scripted. To provide a more natural interactions for participants in our study were able to select controls using a head pointer. We conducted a preliminary study with 12 participants to identify a suitable selection method to enable the user to interact freely with the stateful controls. In a procedural button pressing study, we compared a head pointer method and a hand pointer method. Overall, the head pointer performed better in terms of selection and interaction time, and less physical strain was reported by the participants. In our main user study, we had 3 conditions. 1 aligned condition without haptic retargeting, and 2 remapped conditions with haptic retargeting and the 2 different synchronization methods. The aligned condition represented an ideal passive haptic interface where every physical control is aligned with a corresponding virtual control. The aligned condition also incorporated automatic synchronization to enable the virtual controls to be randomized in each trial. As such, we did not draw any conclusions from comparisons between the aligned and manual remapped conditions. In each condition and each task group, participants saw 3 of each control type, one at a time, aligned with the corresponding controls on the physical interface. In the remapped conditions, only the center physical control was used for all 3 virtual controls. In the aligned condition, each physical control is used for its corresponding virtual control. To complete the tasks, participants selected and then set each control to an indicated position. When the task was complete, it would highlight green. Using the head pointer, the participants could complete any of the 3 visible tasks for a given control type in any order. In our results, we found that the condition with the aligned interface had significantly lower task completion time than the auto-remapped condition with the remapped interface. We expected that the manual synchronization would take longer given the necessity to move the controls twice. This was confirmed with the completion times for our auto-remapped condition being significantly lower than the manual remapped condition. For task load and usability, we noticed a general trend toward the aligned interface. However, we found no statistical significance in these results. With the aligned interface, participants reported higher body ownership, more accurate hand movements, and better alignment between the physical and virtual interface than the auto-remapped condition. Only 4 of the 24 participants preferred the remapped interface over the aligned interface. One participant mentioned that they enjoyed not having to move as far with the remapped interface, and another found the remapped interface more fun to use, though they preferred the aligned interface only because it was more practical. Some participants commented that the aligned interface felt more natural and that they could feel the retargeting. This was expected as the angular gain of our haptic retargeting was approximately 15.2 degrees due to the physical arrangement of our controls. This level of gain exceeds known detection thresholds. 4 participants preferred the manual method over the automatic method. One commented that the sound of the automatic corrections affected their immersion. Participants that preferred the automatic synchronization mentioned that the manual method was more confusing or cumbersome, while the automatic required less effort. The techniques presented in this paper enable the creation of remapped interfaces with more control types. These interfaces are dynamic and reconfigurable, but the use of haptic retargeting reduces task performance and overall usability. More work is required to improve the overall performance of remapped interfaces. Our automatic synchronization method was generally better than the manual sync for task performance. That said, manual sync supports more diverse physical interfaces. It doesn't require custom-built controls, and it can be applied to existing physical interfaces. There may be alternative ways of visualizing the manual correction that could make it less confusing for users. In future work, we would like to evaluate the usability of our system with a task where the user has full autonomy over how they use the interface. We are currently exploring applications such as immersive simulators for training and developing a tool where users can configure their own virtual interface while retaining haptic feedback. Finally, we would like to integrate other advancements such as blink suppressed hand direction and target prediction methods for haptic retargeting. Thank you for watching, and please read our paper or contact us if you are looking for more details.